guys, welcome back to my YouTube channel. I'm back with another video which is very interesting and which is very informative about the current scenarios which is very commonly discussed, that is wireless cellular communication. We'll be seeing in today's session we'll be discussing about the different technological methods which is used for wireless cellular communication. And myself Chandana, I'm from Sri Venkateshwara College of Engineering doing my final years in electronics and communication domain. Without any further delay, let's get into the main topic. Okay, guys, let us see the introduction about wireless cellular communication. Here we can see wireless cellular and communication technologies have been at the forefront of the digital revolution, pro profoundly transforming how we live, work, and interact. These technologies encompass a broad range of methods and standard designs to facilitate the wireless transmission of data, voice across vast distances, which the voice has to be transferred from various distances without need of physical connection like wires or cables. Without the presence of wires or cables, that is called as wireless communication, as we all know. Over the years, evolution from 1G to 5G, current 5G, and the anticipation of 6G has marked significant milestones in this journey, each generation bringing advancement in each generation. They are bringing advancements, which means they are improving in speed, capacity, and this efficiency. These are the main three categories which depend on upbringing the generation from 1G to now it is 6G. This is about the introduction of wireless cellular communication. Let us see what is wireless cellular communication before getting to know the methodologies which is used in this wireless cellular communication. Wireless cellular communication refer to the technology and system that enable the transmission of voice, data, and other type of information without using any physical connections like wire or cables. As we know, wireless communication will transfer the data like voice and PDF or whatever it is, which is known as data, in type of information without using the physical connection like wires or cables. This form of connection utilizes electromagnetic waves to carry signals over distances. While transmitting the data from one end to the other end, they use electromagnetic waves to carry the signals over the distances, allowing mobile to access the communication network from virtually anywhere. This essence of wireless communication lies in its ability to provide real-time, efficient, and flex. This will provide real-time, efficient, and flexible communication options for personal, commercial, and industrial uses. By using this electromagnetic waves, this carries the signals from one end to the other end, which this also enhances wireless communication, and they also provide real-time, efficient, flexible communication options for it can be personal or it can be commercial like one to one like the companies, or it can also be like be the industrial applications. Now let us see what is the key components of wireless cellular and communication system. Like what are the basic key components which is required for establishing wireless communication. There are four basic requirements, which is cellular network, satellites, radio waves, and wireless devices. First, let us see cellular networks. These are composed of cells which serves by a fixed location transversal base station. It is like a base station. These network allow mobile phone and other cellular device to connect to the telecommunication network. This will allow this base station, which is fixed location transceiver. You can see it is acts as a transmitter and also receiver, and this is called transceiver. This device is connected to telecommunication network. The mobile has seen evolution from 1G to 5G. Even now we are using 6G also networks. Each generation offers significant improvement. As I told, the improvement is speed, capacity, and efficiency. Next is the satellites. Used for wide area or global coverage, satellite communication can serve area where terrestrial infrastructure is not feasible or too costly. This includes deep rural or remote regions and is also crucial for global positioning system, which is GPS. Satellite is a very main key component for wireless communication, which also plays very important role in the process. Satellite TV, certain type of internet connectivity. Next is radio waves. Like I told, it uses radio waves, electromagnetic waves to transfer the signal from one end to other end. This radio waves carries the signals that is to be transmitted. Radio waves, the primary medium through which wireless communication is made possible. Different frequencies and technologies such as FM, AM, radio wave, Bluetooth, and Wi-Fi. Radio waves which has FM, AM, Bluetooth, Wi-Fi, and many other things. Utilizes radio waves to transmit data, access short and long across short and long distance. It can be used for short distances as well as long distances. Next is wireless devices. These include, like, it is a basic things like mobile phones, handheld devices, PDAs, wireless sensors, also all of which rely on wireless communication technology to connect with each other and with internet. So these are the four basic key components, which is cellular networks, satellites, radio waves, and wireless devices. Next, it is the technological methods. In for technological methods, I have discussed totally 7 technologies. So let us see one by one. One by one, let us see what are the technologies that is most frequently used in wireless, cellular, and communication. First methodology is 5G and beyond. 5G, the fifth generation of cellular technology. 5G promises much faster data rates, reduces latency, energy saving, cost reduction, higher system capacity, and massive device connectivity. These are all the features of 5G technology, which is faster data rates, reduced latency, energy savings, cost reduction, high system capacity, massive device connectivity. It is being rolled out globally with improvements in network slicing. Like, it is improved by using network slicing, edge computing, and massive MIMO, that is multiple input, multiple output technologies. We have also discussed all these methods here. Next, let us see towards 6G. While 5G is still being deployed, research in 6G has already begun. 6G is actually, even 6G is being deployed, and 5G is also being deployed, and it isn't used. 6G is expected to revolutionize the wireless communication landscape further by providing even faster speeds, low latency, and a high reliability. Next, let us see massive input output. Massive multiple input and multiple output. Here you can see the basic structure of massive multiple input and multiple output. Here you can see user 1 and user 2. This will be the channel transfer function, like it will be the transmitter, and this can be the receiver, or this can be transmitter and it can also be the receiver. Let us see what is massive MIMO. Massive multiple input multiple output technology involves using a large number of antennas at the base station. They use large number of antennas at base station to serve many users simultaneously. They use large number of antennas because they serve many users at the same time. It significantly increases the capacity of wireless communication without requiring more spectrum. It will not require more spectrum, therefore improving the efficiency of mobile network. Using this, mobile network efficiency is increased. Next is millimeter wave technology. Millimeter wave technology utilizes the largely untapped spectrum band above 24 gigahertz. The spectrum band used in millimeter wave technology is about 24 gigahertz. This allows to unprecedented data rates and capacity, which is crucial for bandwidth demands of modern application. Like, it all gives the answer for all the modern demand of application. However, millimeter technology signal have shorter range and are more susceptible to the obstruction by physical object. It is having shorter range and also reacts for the obstacles by physical object, which necessitates the deployment of more base station for effective coverage. For effective coverage, they need more base station. Here you can see the spectrum band of millimeter wave. Next is network slicing. Network slicing is, it is sliced into the the 4 to 5 categories. Here we can see network slicing is 5G feature that allow a single physical network to be divided into multiple virtual networks. Like one signal network is accessed by multiple virtual networks, enabling operators to provide portions of their network for specific customer uses cases. This could mean creating a slice specifically optimized for IoT devices, like it is mainly used in IoT devices also, with low power and bandwidth requirement, like it should use low power and low bandwidth requirement. With while another slice could be optimized by high speed also. One is low, one is high. That does not disturb the spectrum. If it is needed for high speed, it goes for high speed. If it is needed for lower, it will simultaneously act for the lower power and bandwidth requirement. And low latency application like virtual reality or autonomous vehicles. Next is edge computing. You can see what is edge computing here. It is connected to various devices over here. Edge computing brings computation and data storage closer to the location where it is needed to improve response time and save bandwidth, integrated with 5G and beyond. It is integrated 5G and 6G also. Edge computing supports real-time applications such as automation, driving smart cities, IoTs by processing data locally rather than relying on the central data center. Rather than relying on a central data center, the data is processed locally, like which is connected, which is shorter. There, the data is processed and it is sent. That is about edge computing. Next is IoT and low power wide area networks. IoT and low power wide area networks. You know what? Why is IoT is famous? As you can see in this picture, technologies such as narrowband IoT and LTEM have been developed to support IoT devices. These technologies offer low power consumption, which is vital for devices that need to operate for years on a single battery charge, and wide coverage of IoT applications that require a broad geographical spread, such as agriculture, sensors, and city-wide applications. The last technology which we are discussing is satellite internet, which is also a main key component for wireless communication. Companies like SpaceX, with Starlink project, Amazon Project Kuiper, and others are working on deployment of thousands low Earth orbit satellites to provide high-speed internet access in remote and rural areas. Actually, thanks for SpaceX and Amazon for deploying the low Earth orbit, which provides high-speed internet for rural and remote places, which is the main problem which you are facing in current scenario. This technology could complement terrestrial 5G networks by providing coverages in areas that are difficult or uneconomical to reach with traditional infrastructure. Satellite internet helps for the area which is uneconomical, which is remote or rural areas, and also which lack traditional infrastructure. These are all the technological methods of wireless communication. I hope this video helped you a lot. Thank you for watching. Please hit like, comment, share, and subscribe to my channel, and please support us the same. Bye bye.